Hi my dear students, welcome to ChemistrySR, our chemistry channel. In this video, we are going to discuss about characteristics of chemical equilibrium. ఒక కెమికల్ ఈక్విలిబ్రియం యొక్క క్యారెక్టరిస్టిక్స్ ఎలా ఉంటాయో అబ్జర్వ్ చేద్దాం. ఓకే, let us consider a chemical reaction. For example, hydrogen combines with iodine to give hydrogen iodide. Then the formed hydrogen iodide decomposes which is very unstable. So decomposes to give hydrogen and iodine. Such chemical reactions are called reversible reactions. In these reversible reactions, an equilibrium will establish. The equilibrium state is nothing but the state at which both the forward and backward reactions takes place with the same speed. It's clear. Okay, then when an equilibrium is established, then what are the characteristics? Let's see the characteristics of equilibrium. If in a reversible reaction an equilibrium is established, the first thing that we notice is both the forward and backward reactions takes place with same speed or same rate. Nothing but at equilibrium, both the forward and backward reactions takes place with same rate or speed. Rate are nothing but speed. So at equilibrium, both of the forward and backward reactions takes place with the same speed. Okay na? Sorry. Next one. Actually, at equilibrium, the reaction mixture, if you observe the reaction mixture, it seems to be the reaction stopped. Because some properties like a color, concentration of reactants products, pressure, density, volume, such properties, measurable properties remains unchanged, remains constant. There is no change in color of reaction mixture, there is no change in density, no change in pressure, no change in concentrations of both the reactants and products. So these things indicates the reaction seems to be stopped, but actually the reaction never stops at equilibrium. It is continue to takes place. That's why the equilibrium is said to be dynamic in nature. So equilibrium is dynamic. So actually we can notice one thing. At equilibrium, some properties like color of either reactant or product, color, concentration, density, pressure, volume, etc. Okay na? Etc. remains constant. Okay na? Remains constant at equilibrium. Okay, so at equilibrium these properties remains constant, nothing but there is no change in them. It means the reaction seems to be stopped because nothing is changed. Clear? But we can say one thing. At equilibrium, both the forward and backward reactions takes place with the same speed. It means the amount of reactants converting into products are exactly equal to amount of product consumed to give reactant. Nothing but number of reactant molecules converts to products are exactly equal to number of products formed. It means there is no change in the concentration. So there is no change in color. It means the reaction never stops, but it is continue to take place with the same speed. That's why the equilibrium is said to be dynamic in nature. So we can say chemical equilibrium is dynamic in nature. Okay. Next thing, for an equilibrium state, the change in Gibbs free energy delta G value is 0. So at equilibrium, simply we can say like this. At equilibrium, the change in Gibbs free energy delta G value 0. Okay. Then here we have to observe one thing. If you take hydrogen gas and iodine gas, they combine, slowly give hydrogen iodide. After some time, which is quite unstable, so decomposes or dissociates and starts giving H2 and I2. After some time, the speed of forward and speed of backward become equal. That state is called equilibrium state. Now equilibrium is established when you take hydrogen and iodine as the starting material. Take another vessel having hydrogen iodide. Now you are starting the reaction from products by taking products as the starting material, hydrogen iodide. It is unstable, so dissociates to give hydrogen and iodine, which then again combine to give hydrogen iodide. Here you started with hydrogen iodide, you got equilibrium. Initially you started with hydrogen and iodine, you got equilibrium. What it indicates, the equilibrium is established whether you starts with reactants or products. Nothing but equilibrium is established from either sides of the reaction. So equilibrium is established from either sides of a reversible reaction. Either sides of a reversible reaction. Okay. And next thing, a chemical substance which is added to reaction mixture to speed up is called a catalyst. Okay. Okay. Catalyst doesn't influence or doesn't affect the equilibrium state. During a chemical reaction, if you add some amount of catalyst, it doesn't alter the equilibrium state, doesn't affect the equilibrium state. Moreover, it helps to attain the equilibrium quickly. How? By the addition of catalyst, it increases the speed of the reaction. In case, if a catalyst increases the speed of your forward reaction, hydrogen iodide forms readily, then which dissociates readily to give H2 and I2. It means readily we get an equilibrium. It means a catalyst doesn't alter the equilibrium state of a reaction. It helps to attain the equilibrium readily at. So see, a catalyst doesn't alter the equilibrium state, but it helps to attain the equilibrium. It attains the equilibrium quickly. Okay, that's it. Next one, the last characteristic property of equilibrium, At equilibrium state, both the concentrations of reactants and products are constant. Already we said that concentration remains constant. Whose concentration? Both the reactants and products concentration. I will explain with graphical representation. Clear evident. So, at equilibrium, both the concentrations of reactants and products, both of the concentrations of reactants and products remains constant. Okay, let's see how. For example, let us take time along x direction and concentration along y direction. This is the time t0. Okay, at time t0, nothing but initially the reaction mixture contains. For example, let us take this is the reaction. This is our reversible reaction. Here there is an equilibrium will established. Initially at time t is equal to 0, the vessel contains hydrogen and iodine. Nothing but reactants are predominant. Nothing but their concentration is high. Only reactants are present at a time t is equal to 0 seconds. Right? So initially we have reactants whose concentration is high. So concentration of reactants, active masses or concentration of reactants is high at time t is equal to 0. As the time progresses, the concentration of reactants slowly decreases because they slowly converting into product, so their concentration decreases. Time progress, concentration decreases. After some time, the concentration of reactants remains constant. Okay. Similarly, at time t0, there is no products, right? No products, nothing but initially nothing but only reactants are present, no products. So that initially product concentration 0, as the time progress slowly forms. Slow product concentration increases, after some time it becomes constant. So here there is the constancy. This is the time at which an equilibrium is established. So this graph indicates this is the concentration of products, concentration of reactant. This is the graph indicates at equilibrium the concentration of reactants may be greater than the concentration of products. May be greater. Concentration of reactants greater, concentration of products lesser. Maybe. Suppose if we take time along x direction and concentration along y direction, we know one thing, initially reactant concentration is high. As the time progresses, their concentration decreases and after some time remains constant. Okay. Similarly, slowly decreases and then remains constant. Similarly, as the time progresses, the product concentration increases and remains constant. So this is the concentration of reactants. This indicates concentration of products. But after some time, both of the concentrations remains constant. Then that is the state at which an equilibrium is established. This graph indicates the concentration of reactant at equilibrium is lesser than the concentration of products. So maybe reactant concentration is lesser than the reactant concentration of product. Maybe happen. Sometimes for some chemical reactions, concentration of reactant may be greater. For some chemical reactions, concentration of product may be greater. And similarly, take time along x direction, concentration along y direction. Okay. Obviously, as the time progresses, the concentration of reactant decreases, the concentration of products increases. After some time, both of the concentrations remains constant. Okay na? This is the state at which an equilibrium is established. Okay, here both of the concentrations are constant. Equilibrium is established. This curve indicates in some cases or in some chemical reactions at equilibrium, both of the concentrations of reactants and products are equal. That's it. So during a chemical reaction, the concentration of reactants and products may be equal or not equal. Okay, so these three graph indicates that thing. Okay, so these are the characteristic properties of chemical equilibrium. Okay, I hope you understand. Keep watching. Thank you, but don't forget to like and share to someone.